Hello friends, welcome to EC Academy. In this lecture, let us understand first order stage filters. First, let us understand the first order stage low pass filter. In any filter, we will be having an amplifier stage as well as the filter stage. So, in a first order stage filter, we will be having a combination of resistor and a capacitor at the filter stage. So, a single combination of resistor and capacitor is the first order filter. Here, you need to understand the characteristics of the capacitor. This capacitor will block low frequencies and it will allow high frequency. So this you need to remember, the capacitor will block low frequency and the capacitor will pass or it will allow high frequency. Since we know the reactance of the capacitor is inversely proportional to frequency, so if the frequency is high, the reactance will be low. That's why the capacitor will allow the high frequency, and if the frequency is low, the reactance of the capacitor will be high. That's why it will block the low frequencies. So whenever we are taking a low pass filter, the low pass filter response is shown in this figure. You need to remember, the low pass filter will allow the frequency from 0 to some cutoff frequency to pass, and it will block the frequency above the cutoff frequency. So that's why we will decide the cutoff frequency by taking the formula 1 divided by 2 pi R1 C1. So we will decide what are the frequencies that has to be allowed from 0 to cutoff frequency and which are the frequencies that has to be blocked above FC. In a low pass filter, first we will connect a resistor and then a capacitor. So whenever the frequency is low from 0 to FC, the capacitor will act as open circuit. That's why all the frequencies will be available at the output from 0 to FC. From FC to higher frequency, the capacitor will act as a short circuit. That's why all the frequency will pass through this capacitor and it will flow towards the ground. Hence the output will be 0. So the capacitor for higher frequency from FC and above, it will allow to pass towards the ground. That's why output will be 0. So the frequency from 0 to FC, the capacitor will act as open circuit. Hence all the frequency will be available at the output. So from this we understood that for low frequency, the capacitor will act as open circuit, and for high frequency, the capacitor will act as short circuit. So in a low pass filter, first a resistor is connected, then a capacitor is connected. Figure A shows the non-inverting unity gain first order stage low pass filter. So here the gain of this circuit will be 1. That's why it is known as unity gain, because in the feedback no resistors are connected. Since the input is connected to non-inverting terminal, it is known as non-inverting unity gain low pass filter. The cutoff frequency for this circuit can be calculated using 1 divided by 2 pi R1 C1. So R1 and C1 are these resistor and capacitor that are connected in the circuit. Figure B shows the non-inverting voltage gain. So non-inverting voltage gain, which means it is a low pass filter where the resistor is first connected, then a capacitor is connected towards the ground. So the working is same. For low frequency, the capacitor will act as open circuit, and for high frequency, the capacitor will act as closed circuit. Since we are connecting the resistor across the feedback, the circuit will provide some voltage gain that can be given as R2 divided by R1 plus 1. The cutoff frequency can be found using the formula 1 divided by 2 pi R3 C1. Figure C shows an inverting voltage gain. Since input is connected to inverting terminal, this low pass filter is known as inverting voltage gain. The voltage gain can be obtained by taking the formula minus R2 divided by R1, and the cutoff frequency can be calculated by using the formula 1 divided by 2 pi R2 C1. Now let us understand first order stage high pass filter. If we say first order, which means we are having a single combination of capacitor and resistor. In a high pass filter, first a capacitor will be connected and then the resistor will be connected. So as you can see in this diagram, first capacitor will be connected and then the resistor will be connected towards the ground in the filter stage, and at the amplifier stage we will be having an amplifier. So you need to remember, capacitor will block the low frequencies and it will act as a open circuit, and it will allow high frequencies and it will act as a short circuit for high frequency. Since the reactance of the capacitor is inversely proportional to frequency f, for low frequency it will have high reactance and it will block the low frequency signal, and for high frequency the reactance will be low, hence the capacitor will act as short circuit and allows the high frequency. So this is the response of high pass filter, where the frequency from 0 to Fc will be blocked and the frequency above Fc and higher frequency will be allowed to pass through the filter. Here, whenever the frequency is low, this capacitor will act as open circuit for the frequency from 0 to Fc, and for the frequency from Fc to higher frequency, the capacitor will act as short circuit, hence the frequencies will be available at the output. So this circuit will allow higher frequency and it will block the lower frequency. First circuit is a non-inverting unity gain first order stage high pass filter. Since the gain of the circuit is 1, it is known as unity gain, and input is connected to non-inverting terminal, hence it is known as non-inverting unity gain circuit. The cutoff frequency for this circuit can be calculated by using the formula 1 divided by 2 pi R1 C1. Figure B shows non-inverting voltage gain. Here in the feedback we are connecting two resistors, hence we will get some voltage gain that can be calculated using the formula R2 divided by R1 plus 1, and the cutoff frequency can be calculated using the formula 1 divided by 2 pi R3 C1. Figure C shows the inverting voltage gain. Here the input is connected to inverting terminal, hence it is known as inverting voltage gain. The voltage gain can be calculated using the formula minus C1 divided by C2, which are the capacitors that are connected in the circuit, and the cutoff frequency can be calculated using the formula 1 divided by 2 pi R1 C2. So this is about first order stage filters. Hope you have understood the topic. Thank you.